In this video, we'll have a look at how to calculate the total surface area of a composite 3D shape. When you're finding the total surface area of a composite shape, there are two different methods you could use. The first one is drawing a net, which consists of the individual sides that are present within the composite shape, calculating the area of each of those shapes that make up the composite shape, and then adding all of those shapes together to find the total surface area. The second method is by using formulas that you know for total surface area of 3D shapes. First you need to do is break the composite 3D shape into smaller shapes, calculate the total surface area of each of those individual shapes. If those shapes join and some of the area of the individual shapes disappear, you need to calculate the area of the joins and then add all of the individual shapes together and subtract any joining sides. There are the two methods you can use when calculating the total surface area of a composite shape. So let's have a look at an example and see how we can apply each of these methods. In this example, we want to find the total surface area of the 3D composite shape shown. And by looking at the composite shape, we can see that it is made up of a triangular prism and a cylinder that has been cut into half. To calculate the total surface area, I'm going to create a net of the individual sides of the composite 3D shape, calculate each individual area, and then add them together to reach my total surface area. So I'm going to start off with drawing my net, and the first shape I'm going to start with is the triangle at the base. So coming out of the two sides of the triangle, it's going to be two rectangles. So my first rectangle comes along the side from 4 centimeters, and the second rectangle comes along the bottom, which is the side coming out of the 3 centimeters from the triangle. So the last component that we need to find the total surface area is the half A cylinder that sits on top of the triangular prism. So now we've got our 4 components that we need to calculate. Before we start those calculations, we'll go ahead and put on our measurements. So starting with the triangle, the base of the triangle is 3 centimeters and the height is 4 centimeters. Moving on to the rectangles, my first rectangle, the length is going to be 9 centimeters. The width is going to be 4 centimeters. My second rectangle, the length is going to be 9 centimeters again. This time the width is going to be 3 centimeters. And for my cylinder, the height of my cylinder is going to be 9 centimeters. My radius of the cylinder is going to be half of 5 centimeters. So half of 5 centimeters is 2.5. So now I've got all of the measurements I need to go ahead and calculate each individual component. So starting off with the triangle, I'll call that A. So area of A is going to equal to base times height divided by 2. Substituting in my values, it is going to be 3 times 4 divided by 2, which equals 6 centimeters squared. So I'll add that in to my diagram. Next I'm going to move on to my rectangle, which I'll label B. So area of B is equal to length times width, which is equal to 9 times 4, which is 36 centimeters squared. So again, adding that to my diagram. And my second rectangle, which I'll label C. So area of C is going to be length times width. This time it's 9 times 3, which is equal to 27 centimeters squared. So 27 centimeters squared. And that leaves me now with the half A cylinder to calculate the area of that component. So to calculate the area of my half A cylinder, and that's going to include my half of my circular base and half of the curved side, I can use the formula for the area or the total surface area of a cylinder and then divide it by 2. So I'll call my half a cylinder D. So area of D is equal to the total surface area of a cylinder. So 2 pi r squared plus 2 pi r height, and I need to divide that by 2. So substituting in my values, 2 times pi times 2.5 squared plus 2 times pi times 2.5 times 9, and I need to divide that answer by 2. Working it out on my calculator, that comes to 90.32 centimeters squared. So adding that to my net, and now I have all of the individual components I can add together to calculate my total surface area of the 3D shape. So now I can go ahead and calculate my total surface area. So total surface area is going to equal to area of A, so that's my triangle, and I have one of those at each end, so I need to times it by 2, plus area of B, plus area of C, plus the area of my semi-cylinder, so area D. So going ahead and substituting in those values, 6 times 2 plus 36 plus 27 plus 90.32. Adding them all up together, that gives me a total of 165.32 centimeters squared. So the total surface area of the shape is 165.32 centimeters square. So that's an example of how we can calculate the total surface area of a composite shape by breaking it down into individual components, finding the area of those components and adding them together.